Hello, everybody, and welcome back. My name is Chris, and today we're going to be talking about Langchain. Now, what I'm going to do in this video is introduce a rather complex project for a lot of people. For some of you who are more familiar with Langchain and what it can do, this is probably going to be pretty introductory. It's definitely going to be a deeper dive than the last Langchain video, but I just wanted to have a kind of sample project that we can build off of together and then come back and go through all the parts and see how they work and do deep dives on each of those constituent parts. So if you can tell from the collab, we're going to be building a 5e knowledge base. For those of you not familiar, 5e refers to the 5th edition of Dungeons & Dragons. Now, the actual application is totally data agnostic, so you can slot whatever data you want here. One of the most common questions I get from people who are entering into this space is, how do I make this work with my own data, right? How do I get this LLM to know about my data? And honestly, this Langchain ecosystem is probably the easiest way to do that. Is it the only way? Certainly not, right? Like, definitely, absolutely not. But is it a great way? Yes, absolutely. So we're going to walk through today the system, and then in the future, you can expect that we're going to deep dive on each of these points. I just wanted to ground us to a project so that we're all on the same page. So first things first, let's see how it works. All right, so here's our final, application. Basically, this is an agent chain that's powering things that we can interact with, and there's a lot going on underneath the hood, but it's always great to start with an example so that you can see where we're going to take this. So first off, I ask it a simple question: what is the highest hit dice class in Dungeons & Dragons? And it returns the correct answer of Barbarian. We ask it a follow-up: what class features does the Barbarian have? And it gives us an answer. Now, in this next section, I want to show you the idea of what this is doing very loosely, right? So we ask it, what are some of the primal path options? Now, notice we didn't say the Barbarian, right? Well, our agent has memory, so it knows that it needs to look up a primal path option for the Barbarian class in D&D 5th edition. Because it has a history of this conversation, it knows what we're talking about. It can fill in the context for us. Very handy. You'll notice that it has this thought, then it has an action. The action is going to be to use this tool. Now, that tool is a tool that we're going to set up today, and it's called the Dungeons & Dragons QA system. The action input, so this is what it's actually asking the tool: what are the primal path options for barbarians in Dungeons & Dragons 5th edition? The agent makes an observation about the response it gets, and this is what it has said. Then it has the thought of, I now know the final answer, because it feels like it's answered our original question. And then we get to see its final answer. Some of the primal path options for barbarians in Dungeons & Dragons 5th edition include Path of Berserker. You get it, right? I mean, the essential idea here is that this agent is taking what we ask it, making a decision about which tool to use, then getting information from the tool, then making some decisions about whether or not it has the final answer, if it has enough context to answer or not. That's the basic idea, right? So we can tell already, LM is the brain here, and the brain's got access to a few different tools, right? Now, I just want to be clear. I'm calling it a brain, but it's not thinking, right? It's just very good at text completion and instruction following. So even though it feels like it is doing reasoning, and it is definitely simulating reasoning or imitating reasoning, it's not actually thinking, right? It's just a large language model. Then we ask it, can you please list all officially supported primal paths? And you'll notice that it goes to this API search. So it Googles it. So it doesn't think that the Dungeons & Dragons QA system will have an answer. So it Googles it, and we get pretty close to the right answer. I ask it a follow-up, knowing that it's missed one, saying, what about Path of the Zealot? And indeed, it says, sorry, I missed it. There you go. You can definitely tell that GPT-4 is powering this by the classic, apology that it gives. And then this is basically just a question asking what player races were in Monster of the Multiverse. And then I encourage it to use Dungeons & Dragons QA system so that it's not just Googling it, to showcase that, yes, indeed, this is more up to date than GPT-4. So you might be thinking to yourself up to this point, hey, actually, Chris, this is all in GPT-4, and you'd be largely correct. But because it has the context of all of D&D, it also has the new source books, which came out, in this case, in 2022, and it has knowledge of something that occurred after GPT-4's training. In fact, if you ask GPT-4 this question with no plugins or extra information, it can't answer it. All right, so that's what we're doing. So how did we make it? Well, first off, we are going to start with this diagram. This diagram is straight up copied over from another very popular diagram that you can find everywhere. I just cleaned it up and added my own touch to it so that I'd be able to parse it out a little bit better. If you find this diagram useful, that's great. If not, you can use the stock one. They're both great. I just wanted to neaten it up just a little bit. So we have a very straightforward process here, right? I mean, all of this sounds so interesting, sounds so cool, sounds so crazy, but it's pretty straightforward, right? But I want to try to break down exactly what's going on, exactly what's happening, so that you can start feeling comfortable using a tool like Langchain to build some applications that do dope stuff. So first things first, we ask a question. That question gets inserted into a prompt of some kind. There is some augmentation that occurs in order for that prompt to be the quote-unquote best prompt for the situation. And that is powered by the LLM, right? So in this case, we're going to be leveraging OpenAI's suite of LLMs, specifically GPT-4, just because it's the best one, so it shows the app off the best. As we go through this Langchain series, we're going to stop and consider how to insert other LLMs so that you don't have to go to OpenAI systems. But for right now, we're going to stick with the OpenAI suite of models. Once we get that prompt into a format that we're happy with, we can then pass it on to our toolchain. Now, our toolchain is going to be basically how we get extra information, right? So the way that we're getting context in this case is through a retrieval QA chain, which means that we're querying over a bunch of documents. There's additional tools. As you saw, we also have a Google search tool. And we have this idea of memory, right? So that our agent can maintain some kind of relevant information, and that lets us interact with it more naturally. This process heavily leans on the LLM in order to generate natural language responses and determine what is the most relevant information of the context provided. So if you remember the last video on LangChain, basically all we did was this part, the search module. Today, we're going to be adding a few more bells and whistles to give it some more character and more power. And last, but certainly not least, and in fact, it's what we do first, is our data indexing chain. Now, this is where we take those personal documents and then we put them into a format that our chains can interact with. So again, the biggest question I get is, how do I get the LLM to understand my data? A lot of people will reach for fine-tuning. I think that's absolutely overkill. Fine-tuning is absolutely fantastic. Don't get me wrong. I love fine-tuning. It's very powerful. Leveraging especially things like instruct tuning is, in fact, how LangChain can even work. So fine-tuning is important. But if what you want is to have your LLM know things, have knowledge related to your personal information, then this data indexing chain is going to be the easiest way to implement that. One of the things I try to be really clear about when we're talking about fine-tuning LLMs, even though this is not technically generally always true, is that we fine-tune for structure, not knowledge. Another way I heard that expresses that same sentiment is fine-tuning for behavioral, not factual. I think that's a very good way to think about fine-tuning. Yes, sure, that's not literally true. You can fine-tune knowledge. It's possible. I mean, Amazon has a great tutorial on how to do that, their Jumpstart tutorial. But what we want to do today is we want to give a ton of new information to our LLM that doesn't know everything about this topic because it wasn't trained on data after 2022, and there's been rules updates since then. And we want to have our LLM be able to leverage that. And we want it to be able to leverage it in a way that's not prohibitively expensive. Now that we got all that out of the way, let's look at how we actually built this thing. First things first, we're going to need a few dependencies. I'm going to install these throughout the notebook. The first piece we're going to be focusing on is this data indexing chain part, where we have a collection of documents, We parse those documents, and then we vectorize those documents and store the embeddings in a vector database. So let's look and see how we did that. So because I'm using data that's personal, Dungeons & Dragons information is not open source. Unfortunately, I'm not able to provide a resource for it. Though if you're very clever, I'm sure you can find some online. And so that's why I don't actually provide the link to the data in this notebook. Again, if you're looking for it, it exists. I'm sure you can find it. But this is more meant to be representative of the fact you can add whatever data you want. Now, the way that I got my data meant that it was all in JSON. So we're going to use the JSON loader as well as the directory loader to import all of the JSONs from the parent directory that I had. You'll notice that we have this directory loader, which just basically wraps this particular loader class, which is our JSON loader, in a loop that can parse through the directories that you pointed at. So to be clear, this part is just loading in our documents. We're just taking in all the information we have that's basically just hundreds of JSON files, and we're just grabbing it into memory and putting it into a big old list. And you can see what some of the sample data looks like. We have our page content, we have our name, which is Aarakocra, we have our source, which is EEPC, and then we have a bunch of information about them. So what this is it's basically just a big old dump of the page content. So what we want to do is load all those documents. Now, we're not doing anything particularly fancy here. Again, we're just basically cramming all that information into a big list, and that's it. Now, we use our recursive character text splitter to break those potentially huge documents into smaller, manageable chunks. We can see that we go from 1,304 parent documents to many, over 63,000 split documents. You can play around with these values. They are absolutely not locked in at all. Getting these values right is pretty critical. So we're going to spend some time talking about how we can ensure that we're doing that when we actually do a deep dive on loading our documentation. So if you feel like we're just kind of glazing over this, choosing random numbers, it's because for the most part, we're glazing over it and choosing random numbers. Not random, but not well thought out numbers. And again, this is just to showcase the final project, the final thing, and then we're going to talk about how we can get there, what we can change, and how we can make it better as we go through each of these parts more in depth. Now that we have our document split into bite-sized pieces, it's finally time to involve OpenAI, where we're going to use it to generate our embeddings. This is done simply by adding our OpenAI embeddings as our embeddings function. Hype. We're going to need to install a few additional dependencies because we're going to leverage, of course, the open source ChromaDB as well as tick token, which is just a requirement thanks to the fact that we're using the OpenAI embeddings. Once we install those, we're going to persist our directory. The reason we're persisting our directory is because embedding takes a very long time because there are very many documents, right? So we want to be able to not have to embed them every time we load this thing. And this way we can store them locally in this vector DB folder, which you can see here, which is going to have all of the information that we've embedded. After that, it's as simple as calling Chroma from documents using our embeddings, our documents, and of course, our persist directory. This is basically just showing off the fact that it works. So you persist it, then you set it to none, and then you load it up. One thing I want to make clear is that when we use this particular from documents method, we are calling OpenAI, and it's a lot. We have to embed everything, and so that is costly, right? So persisting whatever you've done is absolutely huge, both in terms of loading. This cell took 10 minutes to run, as you can tell. This cell took 3 seconds to run, and this one cost more than $0. This one cost $0. So there's a big reason to persist your embeddings. We don't want to have to do that work twice. Sure, if information updates, you might need to re-embed some of your information. That's absolutely possible. But for now, we're just going to concern ourselves with this one step. And that's the piece to get our information into our ChromaDB. So we've done all of the steps here. We collected a bunch of personal documents. We parsed them. Mostly what this means is we loaded them using the directory loader, which was wrapping our JSON loader. Then we vectorized them, generated embeddings as part of the process of creating our Chroma vector DB. And then we've persisted that DB so that it's available to us in that directory and we don't lose it between sessions. Now, if you are using Colab to do this, in order to really persist it between sessions, what you're going to want to do is to mount your G drive, and then you can save the Chroma DB in your G drive as long as you have space. That's going to make sure that even if you crash your session or walk away for 2 months, you can come back and load it up from that directory in your G drive. Next up is our tool chain. We have our tool augmentation module, our search module, our memory buffer, and that's it. So let's look and see how we actually set this thing up in the first place. So number one, we have our LLM. Again, we're just using GPT-4. You could use anything here. Really, you could use anything here. You could make a custom function or a custom LLM. You know, you can use Hugging Face. The sky's the limit here. And we're going to talk about all of that as we progress through the series. But for right now, again, we just want to have something that we're building towards. And I want to be clear here. We're going to go in depth on each of these steps individually. So I'm going to say some things right now that you might not understand. I know a large portion of you are likely to, but if you don't, please don't worry. The information's coming down the pipeline. I just want to reiterate that we're grounding ourselves with this project so that we have some end goal in mind, but we're not specifically talking about the detailed implementation of each of these steps today. What we're going to do is we're going to set up our vector database as a retriever and call that doc retriever. What this is going to do is it's going to let us take our query and then get relevant documents. Now, again, we're going to deep dive on what relevant documents means, but for now, you can think of it as documents that are similar in meaning to the query. Then we're going to set up our first chain, which is our retrieval QA chain. And this is just going to be powered by our LLM. It's going to use the refine chain type, and it's going to use our doc retriever as the retriever. These decisions might not be meaningful to you, but I hope that in the videos to come, you'll gain real insight into why we're choosing what we're choosing. We can test out this chain by itself. What class has a D12 hit dice? And it gives us this excellent answer. In Dungeons & Dragons 5th edition, the Barbarian class has a hit dice, blah, blah, blah. It also gives us extra context. It's great. It's cool. You love to see it. Next up, we're going to set a search tool, which is our SERP API. This is to allow our particular application to go beyond the bounds of the actual docs themselves and move into the world of a Google search, right? So if it doesn't know something or doesn't think that the tool is suitable for the job, you can still answer that question. Yes, there are a lot of things that we could do to refine this process, and we can talk about those when we get here, but for now, it just searches Google. That's what it does. Now we have to set them into tools, right? So we have these two chains, so we have this chain and this wrapper, and now we need to set it up into a list of actual tools. So our two tools are, we have the Dungeons & Dragons QA system. You'll see that each tool is set up with a name, a function, and a description. The name is great, but it's just signifying what it does. The function is the thing that it's going to use. So that's in this case, this is the D&D QA chain. And it calls the .run method on that chain. So it's going to call that on our query. The description is what the agent can use to decide if this is an appropriate tool or not. So this is actually another place where we can do prompt engineering, right? Because we want our agent to pick the best tools, and so we should write clear and concise descriptions so it knows which tool is best for which job. And then, of course, we have the ability to have our SERP API search, and this is for we can't use any other tools. Now we're going to add some memory. So what's the best memory to add? Well, first of all, we're going to add the conversation buffer memory, which is our entire chat history essentially, and then we're going to add some read-only shared memory. Now this is memory that can't be modified by the tool using it. That's important because we can let the tool be aware of things, but we're not letting it write memories itself. Then we're going to set up the prompt for our zero-shot agent. Now this is absolutely the best place to do really good prompt engineering, right? We can get very specific with what this agent can do, what it can use, when it should use it. We also have to give it a couple things. Number one is this chat history, then our query, and then this agent scratch pad. That scratch pad is going to be what lets it simulate decision-making and reasoning skills. So it's a really important include here into our suffix. We set up this prompt, and then we're going to go through the process of creating our agent. We're going to power its brain with this LLM, which is just the bare LLM chain. Because we're not doing QA retrieval or anything like that with this particular part of the agent, then we don't need to use anything but that LLM chain. You can definitely do other things here, but for now, we're going to leave it with this. We set up our zero-shot agent with our LLM chain. We give it its tools, and then we create the agent chain, which is an agent executor, which is from our agents and tools. We pass our agent, we pass our tools, we pass our memory, and away we go. So if you're feeling overwhelmed by the end of this, well, there's a lot of information, Chris. Don't worry, we're going to be breaking it down over the next series of videos. You can expect that we're going to do deep dives on each of these particular modules. And by the end of that, we're going to see where we can take this quickly cobbled together but fairly workable system and convert it into something more impressive, that works exactly how we want it, and has access to all kinds of fun tools. Like, wouldn't it be neat if this could roll dice, right? So that's where we're going to take this. For now, guys, thanks so much for watching the video. Hope you enjoyed it. If you do, please click the like button and consider subscribing. I hope you have an excellent day, and we will see you in the next one.